Hello everyone. Today we will be solving the question number 1291, sequential digits, which is marked as medium. And yeah, let's try and get to the solution. So, an integer has sequential digits if and only if each digit in the number is one more than the previous digit. So, what does it mean is that if suppose we have one integer 1, 2, 3. So it is sequential digits if and only if the number before 2 here should be 2 minus 1, which is 1. The number before 3 here should be 3 minus 1, which is equals to 2. And here we can see that before 2 we have 1 and before 3 we have 2. So this integer satisfies the given equation or the prerequisite condition. Let's check for one more integer. Uh, 4, 5, 6. Here, the number before 5 should be 1 more than its previous, 1 more than the previous digit. So, number before 5 should be 5 minus 1, which is equals to 4, which is true, 4, 5. And for 6, it should be 6 minus 1, which is equals to 5, which is also true. So, we can say that this integer also satisfy the given condition. Let's try one for one more, like 2, 4, 6. For the number to be in sequential manner, the number before 4 should be 4 minus 1, which is equals to 3, which is not the case here because the number before 4 here is 2. So this number does not satisfy the given condition. So we need to find such numbers which are sequential, like the number before the current number should be 1 less than it. Okay, let's move to the next condition given in the question. Return a sorted list of all the integers in the range low to high, inclusive that they have sequential digits. So we will be given two numbers. One will be low and one will be high, which marks the range of a required answer for suppose 1, 2 and 4, 5. So our answer should be 1, 2, 2, 3, 3, 4, 4, 5. And you can see that 12 and 4, 5, which are also the limits, lower and upper limits, they are also included in the answer. So we need to include the range as well. So let's move to another thinking, like how we should find all the numbers between the given range. Like how will we get the answers? How to form the numbers? Okay. So let's first check all the possible ranges. Like for two digits is 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, and 9, 0 will not be a part of it because in all the previous numbers the given equation or the requirement is satisfied, but here we see that the number before 0 should be 1 less than it, and 9 is not 1 less than it, so 9, 0 does not satisfy the condition. For three digits 1, 2, 3, 2, 3, 4, 3, 4, 5 till 7, 8, 9. Would 890 be in this integer or the set is required vector list? No, because in this equation number as well, 0 is the element or the number which is hindering this pattern, because the number before 0 should be 1 less than it, and 9 is not 1 less than it. So for three digits it is till 789. Likewise, we try 9 digits: 1, 2, 3, 4, 5, 6, 7, 8, 9. Will 2, 3, 4, 5, 6, 7, 8, 9, 0 be a part? No. Once again, due to the fact that 0 is behind 9 and 9 is not 1 less than 0. So for 9 digits only there is one possible integer. So we can find one pattern that for 2 digits the numbers first the number at first occurrence is from 1 to 8. For 3 it is 1 to 7, and for 9 it is for 1 only. So for k digits we can say that number can start from 1 till 10 minus k. For 9 digit it will be 1 to 10 minus 9, which is equals to 1. For 3 it will be 1 to 10 minus 3 equals to 7. So we can say that we can find one pattern that what are the possible numbers and the possible values which are possible for k digits. So let's try to find how many total are there. Here we can say that total 8 integers are present. Here 7, and likewise here 1. So we have total 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. The 8 is for 1 digit, 7 for 2, 6 for 3. 8 is for 2 digits, 7 is for 3, 4, 5, 6, 7, 8, 9, which is a finite number. So why don't we just store all these possible, like the list of integers that follow this pattern of required condition? It will be, I guess, n plus 1 by 2, which is 36. We have total 36 numbers which can be stored in an array. But what about this 9 digit number? Can it be stored in vector of int? Yes, because in the C++, the range of int is this, which is almost it is more than 10 digit number, and here we have only 9 digit number. So this number can be stored in a vector. So for suppose, just let's enter all the vectors. Suppose all the vectors are a b c d e f g. Elements in the vector are a b c d e f g h I j till z. Let it be named as ARR, which contains all the integers that satisfy the given condition. And we are given low as D and high as J. So now what should be our approach? Like we have all the list of all the valid numbers, and we will sort them or insert them only in the sorted manner, and we will be given two numbers, low and high, which for which we need to find all the integers lying between that. So why can't we just do a binary search? What we will do is, for the low we will just try to find one number, find the number just smaller than it. So what we will do is we will find C, and for J find the number less than equal to J. So we will find J. If we are not able to find j, we will find I. So what we will do is for d, we will find a number just smaller than it, and for j, we will find a number less than equal to j. Here in the case it is high. So here it is c and here it is j. So why don't we get all the numbers between them? Suppose we mark with the index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So j is at index 9 and c is at index 2. So what we will do is we will iterate between 2 to 9, 2 and 9, which here will be d to j, and that is a required answer. All the valid numbers lying between d and j and inclusive. So here it is c at index 2 and here it is j at index 9. So what we will do is then iterate the array from let's mark this index 2 as start and let's mark this index 9 as end. From start plus 1 till end. So we will find all the numbers between them. Yeah. So let's move on to the implementation. First, what we need to do is first step 1, form array of valid integers that satisfy the condition. Second step, find the index, start in this case, at which the number is smaller than low. Third step, find the index and at which the number is less than equal to high. So main difference is that for low we are finding number which is just smaller, and for the high we are finding the number which is less than equal to. Here we can also find the number which is equal to high as well. Now fourth step will be iterate air from start plus 1 till end. So once we have found 2 and 9, we will iterate from 2 plus 1 to 9. Okay, rotation. Here let's first declare an array. Now we need to push all the valid integers, all the integers that here are valid. So how we will do it? So first what we did was all 2 digits, 3 digits, 4 digits till 9 digits. So number of digits. Here it should be less than equal to 9 because we are going from 2 till 9. Now we have what is that we will be forming all the 2 digits, 3 digits and 9 digits. But we have also observed one more pattern is that for 2 digits, the first element or the first digit of all the starting vectors is from 1, like 1, and it is ending till 10 minus k. For 2 it is from 1 till 8, for 3 it is from 1 till 7, and for 9 it is from 1 till 1. So for k digits, for digit k, it should be from 1 to 10 minus k. So uh, hmm, it will be the number of numbers as well, from 1 to what? It should be 10 minus the digits. For 2 it should be 1 to 8, right? Yeah, we are on the correct path. 4 and k. K can start from 1 till what? K less than equals to 10 minus digits, and we can increment it. K. So for digit 2, it should be from 1 to 8, right? Now what we have done is we have got the vertical column 2, 3, 4, 5, 6, 7, 8, 9, and we have also found that from which starting number to till what ending number we will be finding all the integers. So now what we want are the actual stuff, that is the numbers themselves. It is 1, 2, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. So now we need to iterate one more loop which adds those many number of digits in that integer. So suppose our starting integer is 0, and how many times we want to iterate that loop? That is the number of digits, because if we have 2 digits, we will need to form a 2-digit number. If we have 9 digits, we need to form a 9-digit number. So for int, let's give it a name counter. Counter equals to 0 till counter less than digits, and counter plus plus. Okay, so we have got the number of how many times we will do the like for the number of digits, and from which starting number to which ending number, and from how many times, which is how many digits we need to append. But how will we now make the number? Suppose digits equals to 2, k equals to 1. Now counter's value will be 1 and 2. We need to form a number, and starting is 0. So what we need to do is, we can think that start will be 1 first, and then it can be made 1, 2. If k equals to 2, still counter will be the same as number of digits, which is the possible values are than 1 and 2. Start will also be 0 once again. So start value should also start from 2, then made 2, 3. So how will we do is, start equals to start star 10, because we need to add one element to the right. So we will multiply the start by 10. Then what we will do is, see here, so if k equals to 1, and here, okay, counter must be 0, 1, and counter must be 0, 1. For if k equals to 1 and counter equals to 0, first is 1. If k equals to 2 and counter is 0, the first number is 2. So we are going on a valid uh, path. If k equals to 2 and then counter equals to 1, then 2 plus 1, 3, we are adding 3. So why don't we just simply add k plus counter and later push it into array. For let's check if the correct numbers are being pushed, and to check we must return something, and as of now we will return temporary empty array. Okay, so we can see that 1 2 2 3 3 4 all valid numbers are being pushed. So now since our first step here of form a array of valid integers has been satisfied, now let's move to the second step, which is find index start at which number is smaller than low. What we will implement is we will do a binary search. Int l equals to 0, and we have found that the total number of elements here will be 36. So why don't so the last index will be 35, so r will be 35, and as we know that for binary search we will be doing till while l less than equal to r, and to prevent overflow we use this, and this this method does not allow overflow, whereas this causes overflow, can cause overflow, so we do not use this method, and rather this. If array of mid greater than equals to low, what we need is that a number has been found bigger than the low. We do not want bigger than, so we will move r to the mid minus 1. If it moves to else, we can say that a lesser number is found. So in grid of finding a bigger number than the found but smaller than the low, we still try for this. And the final answer, this is a short trick. The final answer is always r when we want to find the number just smaller than the given number. For finding the number smaller than given number, r is the answer. Now we have found r. Now we will do find the end index such that number is equal to i. So we will reposition L and R. Standard binary search and prevent overflow. So if array of mid greater than high, we move to the lower boundaries. So what we do is, so r equals to mid minus 1, and in this case l equals to mid plus 1. Let's check here. And here one more, once again, for smaller than p1, binary search answer is at r. So n equals to r. Now we have found start and end. Now we will find the required answer. Let's declare this error. And what we have seen is that here we have found 2 and 9, but we start the iteration from 2 plus 1. It is start plus 1. So for in I equals to start plus 1 until end I plus plus, we push back the answer. And let's check, return the answer. Here, as you can see that we have found the correct output. Let's remove this C out. It may take time. It may not take time for the precautionary side. Let's try submitting. First, we should run once again, because by chance you may comment out other code and you may get incorrect submission. Yep, our answer is correct. We have bit 100%, and we have used no comparatively more memory, because this extra space is required and everyone has used it. So we are in the better position. So don't worry. So do tell me how was the video. If you have any feedback, if some you were not able to understand something, please let me know. I'll work upon it. Thank you.